Okay, this is our study guide for the second half of Unit 5B, Unit 5, excuse me, second half of Unit 5 means 5B. I will be going over all the questions of our study guide and reminding you of things that you need to do on the test. So check yourself when you're going over it to see how you answered the question. And if if your answers are different and don't understand what you did, you can email me or come see me. Okay, so to start off with, we have to graph each function and make sure you show the key points. So I will tell you that on the test, I have boxes. I have two boxes in each place, and it's going to say X and Y. And what you're going to do is put in the key points that go with it. So you're going to show me the key points for the parent function, which is just y equals e to the x, negative 1, 0, 1, e, 1, and 1 over e. And then I have a second box with x and y. And if you want to write on top of it or however you want to do it, okay? So when you're looking at this 3, this affects the x because it's up with the exponent, and I'm going to add 3 to each x value, and I'm going to subtract 2 from each y value. And back to this, the exponential function, okay? We talked about this for anybody having trouble remembering, but um, whatever side the negative 1 and 0 on, the asymptote is the other one. So this asymptote is y equals 0. And whatever I do to my y, I'm going to do the same thing to my asymptote. So it's going to be y minus 2. Okay, pause for 1 second, please. Okay, so we continue each of these. So I'm going to add 3 to each of these numbers, and negative 1 plus 3 is 2. 0 plus 3 is 3, and 1 plus 3 is 4. And then I'm going to subtract 2 from each of those. So that's 1 over e. Doesn't look like an e. Let me take that back. 1 over e minus 2. And then 1 minus 2. And then e minus 2. Okay? Now, when you fill in the boxes, you can leave it like that, or you can write what that decimal approximation is. Okay? So I'm going to put an asymptote on here. My asymptote is y equals negative 2. And then I'm going to plot my points. So I have 2 and then 1 over e minus 2, which is going to be about right here. Okay, and then I have 3, negative 1, and I have 4 e minus 2, and that's going to be about right there. And then you're going to do your best to connect and make sure that you show me which one is approaching the asymptote. Okay, domain for our exponential function is always and never changes negative infinity to infinity. The range, okay, whether you choose to, we did it here mathematically. We just looked at it and said, whatever I do to the y, I do the same thing to the asymptote. Or you can look at your graph and remember that the lowest point that we would ever have, it gets close and close and close, but never touches negative 2. And if this arrow keeps going, then it's positive infinity. Asymptote we figured out was always y equals negative 2. And if your asymptote is y equals, that's going to change your range from 0. So these two should be closely tied together. Okay, intercepts. We have an intercept. Okay, so when you look at your graph, you need to decide, does it cross both axes? And it does. This one is when x equals 0. So if I put x equal to 0, that's going to be e to the negative 3 minus 2. Okay, now if you want to go figure out what that decimal is, absolutely go for it. It ends up being negative 1.95. So I'm going to look at that, and that's looking like about where I've graphed it. Okay, the other one is, what if I put in 0 for y? And if I put in 0 for y, I'm going to go do it up here. Okay, so if I put in 0 for y, I'm going to have 0 equals e to the x minus 3 minus 2. This is a good warm-up, y'all, for what you're fixing to do on the next problems, but it's really, really important for you to understand how to find the x and y-intercepts. So I'm going to take my 2 over by adding, so 2 equals e to the x minus 3. And then if I'm trying to solve for the variable in the exponent, I'm going to take the ln of both sides. So ln of 2 equals the ln of e to the x minus 3. And y'all are pretty good at knowing that means that this side becomes x minus 3. This stays ln of 2. And to bring the 3 over, that's going to give me, I don't think I have enough room to write this. So let's go ln of 2 plus 3, comma, 0. Now, again, put that in your calculator and you will find out that that's about 3.69, which is a little bit more than halfway on my graph, but close enough. I'm between 3 and 4. So, you got that idea. Hopefully that helps. All right, now that's your exponential. This is your logarithmic. So when you write these key points, know that my -1, 0, and 1 are now going to be on the other side. Okay, and you're going to have to fill in these charts. The other thing that I've told people, that L right there, that helps you remember, or it should help you remember, that when you draw your asymptote, it's normally at x equals 0. Okay, so that's the one that we start off with, x equals 0, -1, 0, 1, e, 1, and 1 over e. And then I'm looking at these, and I'm thinking this 1/2 affects my y, this 4 affects my x, this 3 affects my y. So I still have a lot of people that are confused when you have two things. But first of all, let's go with the x. So what happens with this x? All right, again, the chart's going to say x and y tomorrow, so you're going to fill that in and tell me that what do I do to each x value? I'm going to add 4. What do I do to each y value? I have two things to do. And when you have two things to do, you need to remember your order of operations. So I do the 1/2 first. I'm going to multiply by 1/2, and then I'm going to add 3. So that means that my 2 points, if I add 4 to each of these, that's 4 plus 1 over e, and 4 plus 1, and then 4 plus e. Okay, what am I doing to each of these? -1 times 1/2 is -1/2, plus 3 is 2.5. 1/2 times 0 is 0, and 0 plus 3 is 3. And then 1 times 1/2, 1 times 1/2 is 1/2, plus 3 is 3.5. And what happened to my asymptote? What did I do to my x's? I added 4. So I'm going to add 4 to this. So my asymptote is x equals 4. 1, 2, 3, 4. So we're right here. And excuse me, I'm going to plot my points. So at 4, and then I go 1 over e, I'm at 2.5. So 2, 1, 2.5. So it's about right here, halfway up. At 5, I'm at 3. And at 4 plus e, which is going to be 6.78, I'm at 3.5. So we're about right here. And so again, I kind of missed that. Let me try that one more time. All right, so we got it. Missed this point too. Make them bigger like y'all do. So there's my graph. Now, when you do one of these, I hope you will look back. Whatever the domain is going to be my range over here, because how are the exponential and logarithmic functions related? Hope you're all yelling at me and telling me they're inverses of each other. They undo each other. My domain, okay, is normally 0 to infinity, but I shifted everything to the right 4 units, so now it's 4 to infinity. This is where it starts and it continues that way. My asymptote, as we have, is x equals 4. So note these two are tied together. X equals in my domain. And my intercepts, okay? Am I ever going to cross the y-axis? I'm never going to cross it because I cannot cross a vertical asymptote ever. So the only one I have to worry about is this one right here, which is when I make this thing equal to 0. So let me come up here and say 0 equals 1/2 ln x minus 4 plus 3. So I'm going to take the 3 to the other side, and that's going to give me -3 equals 1/2 ln of x minus 4. And I'm going to get this guy out of my way and say, we went like gas. Here we go. And then I'm going to get rid of that 1/2, and I do that by multiplying by 2. So ln of x minus 4. And then how do I get rid of this? Is I do the little kick out. What's my base here? It's e. So e to the -6 equals x minus 4. So if I'm solving for x, I would add 4. So my intercept is going to be e to the negative 6 plus 4 comma 0. Now, put that in your calculator, and you're going to find out that that is about 4.002, which is really close to 4. And so that's where we are. Okay, so hope you got those. And if you have any questions, again, email me, come see me. Let's go talk about solving each equation. Okay, now, as I have said, um, we did talk about it on the quiz, we talked about it, or we're talking about right now in your study guide. I prefer probably that you round all of your answers to the nearest 10,000th. I'm going to put an exact answer also. If you want to leave it an exact answer, that is fine with me, but you have to leave it in the simplest form of that exact answer. So I will give both of them, and you decide what you want to do. If you give me the wrong one, the exact form not simplified, then you will lose some points. So if you want to be on the safe side, make sure you know how to put it in your calculator and get decimal answers. Okay, so when you're solving and you have a variable in the exponent, the first thing you should look at is whether or not these two can be written in the same base. So 81 is a power of 3, so I have 3 to the x plus 8 equals 3 to the 4th, because 81 is 3 to the 4th, to the 2x. So I just rewrote the 81 as 3 to the 4th. And then you should remember, what do you do when you raise a power to a power? And that is you multiply the exponents. So 3 to the x plus 8 equals 3 to the 8x. So now I have the bases are the same, and that means if my bases are the same, I can ignore them and set my exponents equal to each other. So that means x plus 8 has to equal 8x. And that, how do I solve that? I'm going to subtract x, so I have 8 equals 7x. And so I would divide by 7. So my answer would be x equals 8 over 7. That is an exact answer in simplest form. Now, if you want to pick up your calculator and give me the decimal approximation for that, then you're going to say that x equals 1.1429. Okay, and that's what it would be as a decimal rounded to the nearest 10,000. So those are the two answers that are acceptable. All right, number 4. Okay, I got a variable in the exponent. I cannot write them in the same base, and so this time we're going to take the log of both sides. Now, you can take the log or you can take the ln. Either one will give you the same answer. Okay, I just use ln because it's easier to write. Okay, now this whole thing up here is in your exponent, this. So when it comes down, okay, and this is what caused a lot of people trouble on the quiz, you need to put that in parentheses because the ln of 5 is multiplied by all of that. And you all knew to get rid of this ln of 5 first, so we're going to divide that, and that leaves you with 3x minus 4 equals ln of 2 over ln of 5. And then, of course, that's a number. We just don't have to pick up our calculator yet. To move the 4 over, I'm going to add. So 3x equals ln of 2 over ln of 5 plus 4. And then to continue solving that, I would divide by 3. So that would be, you can write it like this. So it would be ln of 2 over ln of 5 plus 4 divided by 3, which really, I probably would prefer this problem, if you have something like this, to go ahead and give me the decimal number. So our decimal number would be x equals 1.4769. Okay, what's really important is that you know how to put that in your calculator to get that number. So if you're having trouble, please let me know. All right, number 5. Moving on. So we have log of something minus 2 equals negative 4. And a lot of people say, oh, I can do that little kick out. But you've got to keep in mind when you do this, y'all, you've got to isolate your log first. This is my log. I got to get that by itself. So to get that by itself, that means I got to move this negative 2 to the other side. So I will add. So that's log of x over 7 equals negative 4 plus 2, which is negative 2. And then you're going to remember that your base here is 10. So when you do the little kick out, you have 10 to the negative 2 equals x over 7. 10 to the negative 2 is 1 over 100, and that's x over 7. So how do I solve that? I multiply both sides by 7, which you can do. Show me that. And so that's x equals 7 over 100, which of course, if you prefer the decimal, would be 0.07. So either one of those answers is good. All right, look at number 6. Okay, it's different from number 7 because I have two logs in them. So if I have two logs, I need to combine them. But before I combine them, I got to make sure it's just a log minus a log. So I move that 3 to my exponent, and that gives me log of x cubed minus log of 6 is equal to 2. And then I bring those two together by, because it's subtraction, I'm going to divide their arguments. So that's the log of x cubed over 6 equals 2. And just like we did, we have a base down here that is understood to be 10. So that means 10 squared equals x cubed over 6. And then I'm going to multiply both sides by 6 to get rid of the 6 on that side. So I have x cubed equals 10 to the second times 6 is going to be 600. And how do I solve that? I'm going to take the cube root of both sides. So again, make sure you know how to put that in your calculator, and you will find out that x equals 8.4343. Okay, I need to pause. Be right back. Okay, continuing. We have 3 times ln of x equals 1. So again, before you do any kind of kick out, you've got to isolate this log. So you need to look at this and understand that this part needs to be by itself. So I'm going to divide both sides by 3. So I have ln of x equals 1/3. And then the base of the ln is e. So e to the 1/3 equals x. Now that's an exact answer, and I'm happy if you want to leave it like that. That's absolutely fine with me. If you don't, then you need to make sure you know how to put that in your calculator correctly and get x equals 1.3956. Okay? All right, look at number 8. Number 8, e to the 3x minus 15 equals 12. So again, any kind of thing, whether we're taking the log or we have an e to the x. Before we do any kind of rearranging of taking the log of both sides or using the kickout definition, we got to get that thing by itself. So I'm going to add 15 to both sides, which gives me e to the 3x equals 27. And then I'm going to take the log of both sides because I have a variable in my exponent. Okay? And we've talked about this. ln of e to the 3x equals 3x because those undo each other. They're inverses. Okay? And I caution you, don't skip this step because that's where people, they forget. They take this 3x down and they forget to put this ln over here. And so here we divide by 3, which we talked about in class would be better for you to understand that that's 1/3 the ln, because dividing by 3 is the same thing as multiplying by 1/3, because then this wouldn't be a simplified exact answer. So you would take this up here, and that would give you x equals ln of 27 to the 1/3, which is the same thing as the cube root of 27. And the cube root of 27, of course, is 3. So this is x equals ln of 3. Or if you want the decimal, would be x equals 1.0986. So again, on the test, either of these two are not completely simplified. Simplified. So this is the answer you need to put in the blank to have a proper simplified answer and get full credit. Okay, on to number 9. So again, looking, it's a log problem, so we would be using the little kick out definition to get rid of it, or raising both sides to the e, as we've talked about. And this is my log, and I have my log all by myself, so I'm going to leave that, and I can now use my definition. The base of this is e, so it says e to the fourth equals x minus 3 squared. Okay, if I have something squared, how am I going to solve that? I'm going to take the square root of both sides. So that tells me that plus or minus e, the square root of 4 is 2, or e to the fourth. The square root of e to the fourth is e squared. We've talked about that earlier. And this gives me x minus 3. And so I solve it by adding 3 to both sides. So x equals 3 plus or minus e squared. Again, I'm fine with that answer. If you want to put it in a decimal, that's going to give me 3 plus e squared, which is going to be 10.3891. And 3 minus e squared is going to be negative 4.3891. Okay? So you'll either put the exact answer or answer rounded to the nearest 10,000. Okay, number 10. Here is my, I'm looking for that e to, or my ln, and it's right here, and so I need to isolate it. So I'm going to move the 3 to the other side. So e to the x over 2 equals 4 minus 3, which is 1. And then we take the ln of both sides. Ln of e to the x over 2 equals ln of 1. And this side becomes x over 2. And ln of 1 is one of those that you really ought to know, because that's 0. And when you multiply both sides by 2, you get 2 times 0, which is 0. So our answer is 0. Now, I talked a lot about this during class when we were working on things, so I hope you do realize anytime you get one of these answers, you can go plug it in your calculator. E to the 3 times ln e minus 15 equals, and you should get 12. So if you have it and use the answer button on their calculator, you can always check your answers before you turn in your test and know how you're doing. So if you need some help with that, please come see me. Okay, backside, solve each system algebraically. Okay, um, multiple ways of doing this, so it's whatever you see and whatever's going to be easiest for you. I'm always about making these numbers smaller, so I see there's a common 6 in every term, so I'm actually going to divide everything by 6. And when I do, I'm going to get ln of x minus 2 ln of y equals 4. And then I add these two together, and these cancel out. Give me 0. Negative 6 minus 2 is negative 8 ln of y. 4 plus 4 is 8. So there is that thing I keep talking about. Before you do the kick out or before you take the log, we got to get that by itself. So that means ln of y equals 8 divided by negative 8, which is going to be negative 1. And now I use my kick out and say e to the negative 1 equals y. And then go back and plug it in, and it does not matter where you plug it in. I'm going to use the one with fewer numbers. So I'm going to say negative ln of x minus 6 times the ln of y, and y is this, equals 4. Okay, so we have negative ln of x, and then minus 6, and this right here we all know becomes negative 1. So I have negative ln of x plus 6 equals 4. Negative ln of x equals, how do I get that to the other side? Because I'm trying to get this by itself. I'm going to subtract 6. So ln of x equals 2, because I multiply both sides by negative 1, or divided, however you want to think about it. And so x equals e to the 2. And that's my x, so that means my answer is going to be e squared e to the negative 1. We write it as an ordered pair, and keep in mind, no need to pick up your calculator when you do these problems. Okay, number 12. I have y equals this thing, so I'm going to go plug that thing in for y. So that's going to give me e to the x minus 6 e to the 1/2 x, and then I'm going to take the 27 over. And we've talked about this numerous times, so I hope you can see it. Whenever this is half of that, or this times 2 equals that, then it is quadratic-like, and I can factor it, okay? And I talked about in class, but just so that you can remember, if you had a quadratic in the past and it said x squared minus 6x minus 27 equals 0, and you're trying to factor this thing, remember, you all know that what goes here is x and x. So what I want you to see is that whatever you have right here, you can't see that. Let me get rid of that color. Let's go with that one. Whatever you have right here is what you're going to write right here and right here. So when I'm factoring this, what goes here is e to the 1/2 x, e to the 1/2 x. So you just got to pay attention to whatever this guy is. And then, of course, you all knew that it was 9 and 3. I need the factors of 27 that subtract to give me 6. And that would be 9. And I need a negative 6, so I need a negative 9 and a positive 3. And then we set each factor equal to 0. So e to the 1/2 x equals 9. E to the 1/2 x equals negative 3. And we have talked about an exponential function can't be equal to a negative number, not the parent, so we're good with that. We get to cross that one out. And now I'm going to take the ln of both sides because I'm solving for that variable in the exponent. So I wrote ln on both sides. This simplifies to 1/2 x equals ln of 9. How do I solve that? I multiply by 2, so that's this. But again, that's not in simplified form because this guy can be moved to the exponent. So it's x equals the ln of 9 squared. And what is 9 squared? It is 81. So my x-coordinate is going to be the ln of 81. Now, because y is 1/2 x, you can actually do it right here and say y equals 1/2 of 2 times the ln of 9. And what's 1/2 times 2? It is, they cancel each other out, so I'm just left with the ln of 9. Now, you get the same thing if you put ln of 81 here, you just have to remember that 1/2 becomes the exponent of your 81, so it's the square root of 81, which is 9. So again, you're getting the same thing. Okay, almost done here. Sketch and shade the region enclosed by the graphs. Okay, make sure that you show me your key points in this space here. Okay, and what you're going to be showing me. So this y equals e to the x plus 4. Okay, some kind of key points. Negative 1, 0, 1, and it's e, 1, and 1 over e. And if you know that this goes to whichever one it goes to, then okay, I know it adds 4 to each of these. I'm fine with that, but you're still showing me some kind of work. And my asymptote of y equals 0 is now y equals 0 plus 4. So I'm going to graph that one real quick. I'm up here. And I'm not as, well, that's fine. We'll keep it at that. Okay, so I'm graphing 1 over e plus 4 and 1 plus 4 and then e plus 4. So my graph is looking something like, well, that's really bad. All right, but I don't want to take the time to, you got something like that. That was really bad, but you can, it's easier with pencil. Okay, so my next one is a parabola with a vertex of negative 3, 2. That's my vertex, and there's no a value. My key points are 1, 1, 2, 4, 3, 9. So I can graph at negative 3, positive 2, and then I'm going to go over 1, up 1 in both directions, because those are my over and up numbers, not my points to plot. Over 2, up 4 gets me here. And then over 3 up 9 is actually going to be off our graph, so you actually don't have to plot those. And then we're going to do our best to connect them to make them look like a parabola. Okay? So right now, I have these two regions here, and let's see, it says y equals 1. Oh, Pooh Bear. This is what happens when y'all aren't with me. Um, each of these points, let's just go do them down. It's minus 3 minus 2. So I was supposed to start at negative 3 minus 2, and then go over 1 up 1 on both sides, over 2 up 4, kind of missed that one, and then over 3 up 9, which is putting me right here and here. And let's see if I can get a better parabola. Probably not. Oh golly, that's terrible. But, alright. So I have my parabola. So now I've got it between this green and red. And then I have my last two, my last one, which is y equals 1. And y equals 1 is a line. And this time we need to make sure it's not dotted. Okay, and if it's not dotted, and let's go with this one, y equals 1 is intersects the y-axis. So we're right here. So if I'm looking for this part of the graph that is in between all of these, then that means that I'm shading this. So well, you're not supposed to go above the region. Don't go across your, you do go above the asymptote, okay, because you got to go all the way up to whatever you drew for that line, and then you're stopping at this bottom line. So you're looking for that region such that when you shade it in, you can actually touch um, all of the graphs, and he doesn't want to shade. Let's try that again. There we go. Okay, last three problems. Finish up. Factoring. Find the roots of the function. Okay, so to find those roots, we are setting it equal to 0, and we're looking for that common denominator. Okay, that was the wrong thing. I was supposed to hit highlighter. Ah, it's still not working for me. Highlighter. There we go. All right, and so we found this right here. It's e to the x. Oh, it's negative e to the x in both of them. So I'm going to take out negative. I damn right negative. My bad. Negative e to the negative x. And when I take it out of here, I'm left with x squared plus 5x minus 11. And over here, I'm left with minus 2x minus 7. It's all addition. So no sign changes for anything. You can clean up this second one. So I have negative e to the negative x times x squared plus 3x minus 18. So set each one equal to 0. Can't have an exponential function equal to 0. And this one, when you set it equal to 0, because I'm running out of room, I'm going to go ahead and factor. I'm looking for the factors of 18 that subtract to give me 3, and that would be plus 6 minus 3, and x equals negative 6 or positive 3. And I had some questions just in case your class didn't ask them. I thought it couldn't be negative. Well, it's not the exponent. If I put a negative number into any of these values for x, it's fine. This is the exponential function is what can't be negative. Our x can be negative, and that's fine. Okay, last three problems and we're done. Okay, ln of e to the negative x. Okay, this part right here is equal to negative x, but it's being multiplied by an 8. So your answer is negative 8x. This is because these two undo each other, so my answer is just the exponent. Over here, this part right here is equal to 3, and 3 over 51 becomes 1 over 17. And again, e to the ln, they undo each other, so all that's left is what is my exponent. So I hope that helped. If you have any trouble with your calculator, please email me or come see me, and let me know if you have any questions. There will be a hard copy on the calendar. Thank you. Have a great day.